Hi, my name is Kira Van Winkle, and I'm a science teacher in Iowa. If you're watching this video, it means that you are absent for part or all of the first lesson of a brand new unit in your science class. Before we get started going through the lesson, I would like for you to gather a couple of supplies. You're going to need your science notebook, or you're going to need some blank sheets of paper, and you'll also need a writing utensil. There's going to be handouts that we'll be looking at throughout this lesson, and you can access that handout from the bit.ly link on this slide. If you need a few minutes to go grab your supplies, go ahead and do that. Just pause the video and press play when you're ready to begin. So our new unit begins with us taking a look at something called a natural hazard. So this past winter, I spent some time reading about a specific natural hazard that happens in locations where lots and lots of people live. And when this particular natural hazard happens, it can damage structures like buildings or roads or bridges, but it can also be really, really harmful to humans, and people can even die as a result of this particular phenomenon. It's called a tsunami. This slide shows a tsunami wave reaching the eastern coast of Japan in 2011. We also have a reading that we're going to go through that talks about the events that happened in Japan and Indonesia related to this particular type of natural hazard. Before we begin reading, though, it might be helpful to know where those sorts of things are taking place. If you take a look at this slide, you can see that Japan and Indonesia have been labeled on the map. Knowing where these places are can be helpful to us as we read about the tsunami phenomenon that occurred in these locations. So let's read part 1 of the handout together. Before we begin, though, find a new section in your notebook and title it Tsunami Phenomenon. Then make a 2-column chart to record your noticings in the left column and your wonderings in the right column from the reading and photographs. So you're going to copy what's on this slide. This handout has a copy of the reading, it has images, and it has a lot of other stuff that we're going to be going through as we move through this lesson. You can access it using this bit.ly link, or you can just copy things from the slides as we go. It's totally up to you. If you need a moment to finish creating your chart, go ahead and pause. Otherwise, I'm going to go ahead and get started reading. Part 1, read about a natural hazard. Tsunami, Japan, 2011. On March 11, 2011, a 9.0 magnitude earthquake struck underwater off the eastern coast of Japan. This was felt on land at 2:45 p.m. local time. There were multiple aftershocks, and at 3:14 p.m., a tsunami warning was announced for the coastal areas along the Pacific Ocean, predicting water waves of up to 33 feet high, or 10 meters. Some people living near the coast had only 8 minutes of warning before the waves hit their city, while other residents in other areas had more time. Low-lying cities closer to the earthquake experienced taller waves than those farther away. The tsunami had a major impact on the people who lived in the affected cities across Japan. Over 10,000 people died, many of them carried away by fast-moving water. Over 100,000 buildings totally collapsed. Over 4 million houses in Japan were left without electricity for over a week, and over 1 million households were left without fresh water for over a week. Prior to the 2011 tsunami in Japan, Indonesia had experienced a tsunami on December 26, 2004, triggered by a 9.2 magnitude earthquake in the Indian Ocean. The Indonesian tsunami generated waves as high as 100 feet or 30 meters and killed approximately 227,000 people in 14 different countries along the shorelines of the Indian Ocean, including more than 126,000 in Indonesia. If you need to pause the video for a moment while you record your notices and wonders, feel free to do so. Now that you've recorded your notices and wonders from the reading, draw a line below your notes and take a look at the images on this slide. What do you notice or wonder about these images? Pause here while you record your thoughts and your observations. So we've read about and have looked at photos from a tsunami, so now let's watch a video of a tsunami. As a reminder from our reading, this was a really devastating event that caused a lot of loss of life and physical damage. So, although you've not experienced a tsunami yourself, most likely, you may have experienced other natural hazards or have close family or friends who've been affected by such events. We can't necessarily stop these events, but we can use science to understand them better, predicting when they may occur and make more informed decisions about what to do when they happen. So before I begin the video, draw a line beneath your notices and wonders from the reading and the photographs. Record new notices and wonders from the video. So as you watch, think about learning more about this phenomenon and how that might help us figure out ways to reduce the impacts from events such as this one. Look closely for details about this event, as well as how it impacts people and structures in its area. What's really neat about this video is that we get multiple perspectives of a tsunami. The video does not have sound, so be sure to pay close attention to what you see happening. I'm going to play the video one time since it's a longer video, but feel free to pause or replay the video as needed. make sure to record your notices and wonders about the events and the people and structures that were impacted by the tsunami in your notebook. If you need to watch the video again, feel free to do so now. Just pause the video here until you've finished recording your notices and wonders. So because natural hazards like tsunamis affect people and communities quite frequently, scientists and engineers want to come up with solutions to help protect them. We saw that this natural event can do a lot of damage to land and buildings and other property, and sometimes even human lives. So this motivates people to study why they occur, how they work, and also how to reduce their effects. As scientists get to understand these events better, engineers can use that knowledge to help design solutions to protect or warn us about these natural hazards. So therefore, in this unit, you're going to think like both a scientist and an engineer. So let's think about the tsunami again, but from an engineering perspective. What are some ideas you might have about ways to detect tsunamis or warn people of their approach and reduce the damage that they caused? So I'm sure that you noticed some interesting things from the reading and the photos and the videos. So as you brainstorm engineering ideas, use what you already recorded in your notebook about what you noticed during the tsunami to help you think about how people and communities could be protected and warned in the future. So I'm going to have you copy part 2 from this slide into your notebook, or just access the digital version using the link on this slide. When you get to that the digital handout, you'll have to scroll down to part 2 once you open the file. If you're creating your own version, you're going to need 3 columns. So the left column should say technologies to help detect a tsunami. The middle should say technologies to give people more advanced warning that a tsunami is approaching. And the third right-hand column should say technologies that could help reduce the damage from a tsunami. So take a few minutes and create or access and fill out part 2 of this handout. So pause the video here and then press play when you're ready to move on. So you're copying this into your notebook, and then you're going to brainstorm some ideas of things that could help detect, things that could help give advanced warning, and things that could help reduce the damage from a tsunami. Go ahead and pause. All right, so take a look over your initial brainstorm and choose one of your ideas that you wrote down to expand upon. So you're going to copy this section of the handout into your notebook or add to your paper copy. So create a diagram of how your idea would work. So you're going to make a picture or a model, and then you're going to write a short explanation. And remember to label your diagram so that someone else could understand how your design works. So pause here until you're ready to continue on. Okay, it's often helpful to have multiple ideas for scientists to work from. So maybe choose now one of your ideas from a different category in your brainstorm table, and let's make a diagram of how that idea might work and write a short explanation. So again, you're diagramming a different idea from your list and writing how that might work. So pause here again until you're ready to continue on. So as we close out day 1 of our new unit, be ready to share your ideas from part 2 with your teacher and classmates when you return to class. Science and engineering are like really collaborative disciplines, so it's important that others get a chance to see and hear and provide feedback on your ideas. If you only missed day 1 of this lesson, you can stop the video here. Just be sure to share your notice and wonder chart, your brainstorm ideas, and your diagram of your design ideas with your teacher when you get back to class. If you missed the second day of the lesson, you can go ahead and continue watching the video here. Let's begin day 2 of our first lesson. You're going to need the same materials as we needed on day 1, so your notebook, blank sheets of paper, and a writing utensil, and then you'll also need the design ideas you came up with in part 2 of the handout from day 1. So be sure to have extra paper and a writing utensil or 2 as well, because we're going to be adding to that handout. So, a reminder that on day one, we were introduced to dangerous and devastating events that took place in Japan and Indonesia called tsunamis. So, you created a list of ideas for how we could detect them, warn people of their occurrence, or reduce damage from a tsunami event. So, today, we're going to take a look at a few ideas that other students came up with. So if you could please find part 3 in the tsunami handout or copy this data table into your notebook. You can access the handout using the bit.ly link on this slide, or you can just go ahead and copy this down. I'll have you pause the video here until you're ready to move forward. So take a look at this slide. We have some sample student ideas from another class of some ways that we could detect tsunamis, warn people of them, and then also reduce damage from them. It looks like there's several ideas that have been recorded for each of those categories. So I'd like for you to just take a moment and read through these and then record information about at least 3 of these ideas into your data table for part 3 and make sure that you identify which category they came from. So if I choose the second one under detect tsunamis that says buoys in the ocean that contain sensors, I'm going to write that for person A. And then I'm also going to say that it is the technology that detects tsunamis on my paper. So pause the video here until you are ready to move on. Okay, so part of engineering is coming up with new ideas to solve problems, but engineers also use their expertise to evaluate a plan that's already being used or one that maybe someone has proposed as a potential solution. So, as part of their evaluation, they ask, does this idea show promise or does this idea seem challenging? So, let's try that with the ideas that we have from this student ideas in the previous slide. So move to part 4 in your handout. And again, that's accessible from this bit.ly link. And then you could also copy these questions if you don't have access to the digital version. So the questions you need to write down are which ideas seem to have the most promise and why? And which ideas seem to be the most challenging and why? So I'll wait for a moment so you can jot these questions down if you need to. Okay, so let's take a few minutes now to individually write down the ideas that you think show the most promise and explain your rationale. So write down the ideas that you thought were maybe more promising or easier to implement, and then tell why. And then also do the opposite. So, what are some ideas that may be challenging to implement and explain why? And as a reminder, I almost wanted to say it, we're not looking for good ideas or bad ideas because we really don't know what makes an idea good or bad at this point. So instead, we're just jotting down like our initial impressions as to what might be simpler or more challenging for us to implement. And I'm wondering, as you jot those down, if you notice any patterns when you look at those ideas that you thought were more promising, or whether you noticed any patterns in your challenging ideas. Um, and then just maybe take a couple notes, like what patterns are we noticing as we look through these ideas? Go ahead and pause the video if you need to, and when you're ready, you can press play. Okay, so sometimes deciding whether an idea or is promising or challenging is difficult, as you can see from your list on part 4. So add the question from this slide into your notebook. And the question says, what do we still need to know about these designs or the actual hazard itself? To your notebook, and then take a minute to answer it in your notebook. So pause the video here. You're copying down this question from the slide and then jotting down your ideas for an answer. So, if we can understand more about the process that engineers use to design and evaluate plans, then we can maybe apply it to other natural hazards that happen maybe closer to us. So, to help us do this, whenever we come up with an idea or research a possible solution, let's continue to ask ourselves, what is making this solution promising or challenging? So, we've spent a few days looking at and analyzing information about tsunamis. So, let's think now about other types of natural hazards and how they affect people and places too. And then let's also think about whether we know of any technologies for detecting hazards that are closer to us or for warning people that a hazard's about to occur. So, what other natural hazards have we heard of or experienced? So, for part 5 in your notebook, you're either going to access the handout again and scroll to part 5, or you can create a section in your notebook titled Related Phenomena. So I'd like for you to brainstorm some other ideas of natural hazards that maybe you've experienced or that you were affected by, maybe even that you've heard about, read about, watched videos about, or anything that you're interested in learning more about. So in that related phenomena section, go ahead and take a minute to record your thoughts. And when you're ready to keep going, just press play. So pause here, record your thoughts, and then press play when you're ready to continue. So, in the last unit, we noticed that earthquakes tend to happen more frequently in certain locations, like along the boundaries of plates on Earth's surface. So, this means that communities in those areas are more at risk for experiencing earthquakes. So, think about which natural hazards are more likely to happen in your community. Are there things you know about those hazards that might help us think about design solutions for the tsunami hazard? So find these questions in part 5 of your handout or copy down the questions on this slide into your notebook. I'd like for you to pause the video here and consider these questions and complete your thoughts in writing in your notebook. So just pause and press play when you're ready to continue. All right, so as we finish up this day of the lesson, we should consider experiences of others that we care about. So, for home learning tonight, I'd like for you to share what you've learned about tsunamis with your family, and then ask if they've had or have heard of, sorry, or experienced any other natural hazards. It's going to be helpful for us, I think, to hear about their experiences and what they learned from them. So ask your family members or close people that you care about if they remember when they first experienced the hazard and how they learned about what to do when it happened. So hearing from different people might give us some more ideas about how to help people and communities prepare for when a hazard is occurring in that area. So be sure to share with your teachers and your classmates once you return to school the things that you found out from your home learning. So go ahead and jot down some of these notes if you would like to help have that available as you have that discussion with people whom you care about, and then be ready to share that when you return to the lesson. If you only missed day 2 of this lesson, you can stop the video here. Just be sure to share all that information that's on your tsunami handout with your teacher and your classmates when you get back. And then if you missed the 3rd day of the lesson in class, you can just go ahead and continue watching the video. All right, so let's begin day 3 of our first lesson. Again, you're going to need some of the same materials we needed for days 1 and 2, which were your science notebook or several pieces of blank paper, along with a writing utensil, so a pencil or pen. And it's also potentially going to be helpful to have that handout from days 1 and 2. So parts 1 through 5 of the handout would be very helpful as well, or the notes that you had that you took about those sections of the handout. So let's think about the home learning first that was assigned at the end of day 2, where we were asked to talk with family or friends about natural hazards that they have witnessed and how they prepared for them. So now that we've talked with others about their experiences, we can use what they shared to help us think about how to design ways to protect people and places in the future. So take a minute and think through the questions on this slide. So, what did you learn about natural hazards from your family? And then what surprised you the most after talking with your family? And if you would like to, you can jot down some ideas from your thinking. Just pause the video and press play when you're ready to continue. Okay, so find a new space in your notebook and go ahead and copy these questions down that are on this slide. So the first question says, how do you think people determine which places are at risk for a natural hazard? And then how do you think people compare and evaluate solutions for reducing the impact of a natural hazard? So take a couple of minutes to jot down those questions and then consider those questions and answer them in your notebook. So pause the video here as you answer the questions in your notebook, and then when you're ready to continue, just press play. So we have a lot of questions about tsunamis, and we have ideas about how to reduce their impact, and we have ideas about other natural hazards and maybe even some questions about those, including the things that maybe we learned from our family and friends. So we're going to use that to help us set up our driving question board for this unit. So it's going to be helpful, I think, maybe to have two categories for our questions. So if you take a look at this slide, we're looking at two different columns. The first category is questions about tsunamis and other natural hazards. So the natural hazards themselves. And then the second category is questions about engineering designs for any of those hazards. Okay? So the technologies that might help warn us or reduce the impact from those natural hazards. So you can generate questions in both categories. So if you could please create a T-chart in your notebook with the headings shown in this slide. And then you'll notice that there are a couple of guiding questions listed on the slide that might help you to generate questions for each category. So take a few minutes to create this T-chart and generate questions for each category. So for tsunamis and other natural hazards, you might ask questions about things you find to still be unclear, or what you might want to know more about. And then for engineering designs, think about how we go about designing new solutions to reduce the impact of natural hazards and how we might compare and evaluate different engineering designs related to natural hazards. So as you generate your questions, it might be helpful to look back at your handout from days 1 and 2, that 5-part handout, or the giant chunk of notes that you have in your notebook. But go ahead and generate your list of questions for both categories on this T-chart. Pause the video here, and then once you have your questions generated, go ahead and press play. Okay, so your class will have taken some time to share their questions and organize them into a driving question board that might look similar to the one on your screen, or it might look very different. So be sure to check back in with your class when you return. This particular class had questions like whether or not tsunamis happen at different times of the year, like other natural disasters such as hurricanes or tornadoes. They're wondering where and when the biggest tsunami occurred. They're wondering how tsunamis form. They're trying to figure out what is a safe distance to be from a tsunami. So how close can I be without being in danger? And then what has already been tried in terms of detecting, warning, and reducing damage from tsunamis? And then can buildings be built to resist damage from natural disasters? And can we stop natural disasters from happening altogether? And are there other natural hazards that happen in areas where tsunamis also happen? So is there a chance for like a double whammy of natural hazards? And it's going to be important, again, for you to share your questions that you generated with your teacher and your classmates when you return to class so that your ideas can help guide the class's discussion and learning. So one of the things that came about from the discussion that this class had is that science and engineering seems pretty interconnected. And answering some of the questions about the science part can also help us figure out things about designing solutions and vice versa. So if I figure stuff out about the engineering, maybe it'll help me answer some of the science questions. So this might be something that your class also noticed. So before we move on, let's recall that we've looked closely at one tsunami that devastated Japan in 2011, And we thought about solutions to help people who might experience a tsunami in the future. We also began to think about other natural hazards, so one that might happen close to us, or ones that we've heard about, or that our family members have experienced. And then, based on our thinking about tsunamis, we started to think about how we can detect when other hazards occur, how we can warn people about them, and what we can do to reduce the damage. So, can you think of an idea for a main question that pulls all of these questions together? So, like, what's a question that can help us capture this? So, take a look at your questions and at this slide and write an idea that you have for a main question in your notebook beneath the questions that you wrote. So, pause the video here if you need some time to think and record a question that would encompass all of these things. Okay, so we're at the last part of the first lesson. So we've identified a lot of things that we don't know, but we need to think about how we can go about figuring out the answers to our questions. So what are we thinking about in terms of tsunamis and other hazards? What kind of information do we need to better understand them and to evaluate technologies designed to reduce their impact? So I'd like for you to create a space in your notebook with the heading shown on this slide. So this heading says ideas for investigation and information we need. And I'd like for you to spend a few minutes thinking about the questions you generated yourself, as well as maybe the questions you saw in the sample driving question board on the previous slide. And I want you to think about what are some ideas you have for figuring out more about tsunamis, other natural hazards, and how we might go about evaluating technologies that are designed to reduce their impact. So pause your video here and jot down your ideas for investigation and information that we need. All right, we've now finished the last day of our first lesson. So, your teacher will have gathered questions and ideas for investigation from your classmates, but the ideas and experiences that you bring with you to your classroom are also really important and can be really, really helpful in figuring out more about tsunamis and other natural hazards and technology for reducing their impacts. So, be sure, please, to make sure that you share your ideas and your models with your teacher when you return to your classroom.